Good morning and welcome back. My name is Liz Lempress. I am a proud member of the class of 83 and Thayer School of Engineering class of 84. And it is my privilege to introduce a speaker who really needs no introduction, but I'll take a few minutes anyway. The 12th Dean of the Thayer School of Engineering, Joe Helble. Since joining Thayer in 2005, Joe has led Thayer through, by what any measure is, an exciting period of growth and innovation, and at the same time, focus. He has centered Thayer's research, as we all know, around three major areas of medicine, engineering, energy, and complex systems. During his tenure, the size and most importantly, the quality of every program at Thayer has grown. He's innovated our curriculum, including creating the first PhD program in innovation designed to help people start their careers in entrepreneurship. And for that, he was recognized with the very prestigious Gordon Prize in 2014. Joe will also be remembered when the history of Thayer is written as the leader who brought gender parity to engineering education. And for that, many of us particularly appreciate him. Joe is also an accomplished engineer and academic in his own right, with a specialization in air pollution and nanotechnology. He holds 5 patents in nanoscale ceramic powders, has written over 100 academic articles. His bachelor's degree is in chemical engineering from Lehigh, and his PhD is in chemical engineering from MIT. He is a recipient of the National Science Foundation Career Award. He is an elected member of the Connecticut Academy of Science and Engineering. He has served on numerous panels and councils for the EPA Science Advisory Boards, and he's on the editorial boards of 2 academic journals. We do not know what he does in his spare time other than these endeavors. Joe and his wife, Becky, are the proud parents of 3 children, a role which has recently enabled him to add yet another title to his illustrious credentials, one which I know he is very excited about, and that is Thayer Parent. Ladies and gentlemen, Joe.
Thank you very much, Liz, and thanks everyone for joining us this morning. That was a very gracious and generous introduction, but you know that everything that we've accomplished here has been a collaborative and collective effort of a dedicated and committed faculty and staff, a wonderful alumni community, a supportive board of overseers, and through it all, intellectually curious, open-minded students who are willing to work hard and really engage in challenging themselves to figure out how to use technology to make the world a better place, to do, as I often say, work that improves the human condition. And that really is what's made this such a fun 12 years for me, such an engaging place for all of us to work. I'm going to take a few minutes this morning to try and do a couple of different things. I'm going to speak a bit about the big picture nationally in research, funding, the funding environment, and what that does to enable innovation and why that's so important to us here at Thayer. I will speak about a couple of specific examples of programs and accomplishments at Thayer, talk a bit about our educational history, and embedded in this, I want to walk through a timeline that's a little bit different than the one outside, show you how our faculty, student body, and facilities have changed through 150 years of remarkable history. I'll end by speaking a little bit about the future. You've no doubt noticed the large prop located to my left. Thank you very much, Jeff Immelt, for setting that up quite nicely. But I thought this has been in the Jackson Conference Room for 6 months, and I thought what a wonderful opportunity just to have it here so everyone could get a chance to see it while you're sitting and listening to the presentation, and also perhaps afterwards, and we can talk a bit about our vision for the future of the Thayer School of Engineering. So we're going to try and cover a lot, and I'm going to be very timely because lunch comes right at the end of this. We don't want to keep you from lunch. So in the beginning, A long, long time ago, not in a galaxy far, far away, but right here in Hanover, the Thayer School of Engineering started when General Sylvanus Thayer wrote a letter to Dartmouth President Asa Dodge Smith on April 4th, 1867. And I'm guessing you can't read the text very well, but the first paragraph is worth noting. Of course, now I'm going to show my age and take off my glasses. It says, sometime next year, not later than February probably, I hope to be prepared to place in the hands of trustees the sum of $30,000, the income derived therefrom to be applied to the establishment and maintenance of a department or school. And he goes on from there, extolling the importance of creating a school of engineering associated with Dartmouth College. That $30,000, as those of you who know the history, grew to become $70,000, a staggering sum in its day, presently worth about $1.3 million. An original founding endowment, we can still trace the history of that endowment in our records. It lives on today. And that endowment created for the first time in this country a professional school of engineering focused on complementing an undergraduate general science and philosophy education, what we call today a liberal arts education, and focused on improving the human condition. These are words that are literally carved in granite on the outside of Cummings Hall and the outside of McLean. I would bet many of you know them well, to prepare the most capable and faithful for the most responsible positions in difficult service. This idea that engineering was not about technology for technology's sake, but was about service to humanity, has permeated this school from the very beginning for 150 years, and it's something that we think about here every day. Now, how do we prepare the most capable and faithful? Well, this has always meant teaching and inspiring our students to take on challenging technical problems. That has not changed. Back in the day, it also meant a different kind of work, engaging with the local environment and local civil works. Late 19th century, the need for civil infrastructure, buildings, roads, bridges, waterworks, waste treatment was enormous. The country was industrializing and developing. And so here at Dartmouth, led by Dean Robert Fletcher, Bobby Fletcher, the first dean and professor, Dartmouth Thayer faculty engaged in developing the Hanover Waterworks, building the first version of the Ledyard Bridge over the Connecticut River, no doubt more artistically and aesthetically appealing than the current version, and doing lots of things to help develop the local community. What does it mean today? While we still engage largely through student project work in the local community, it means, in fact, very different things. Our faculty work on developing advanced materials, improving computer security, improving power electronics to enable more efficient utilization of arrays of solar photovoltaic systems, advanced medical imaging, advanced imaging period. For those of you who were able to hear Eric Fossum's talk this morning, you get a sense of some of the very exciting work going on in his laboratory. Developing new vaccines and new pharmaceuticals. Well, a general question is, how does this all happen today in a modern research university? How does it happen in an environment like Thayer? Very, very different today than 150 years ago. Well, the basic premise and the way Thayer faculty go about their research work is as follows. Thayer faculty, being brilliant thinkers, always have ideas. Now, Jeff made an interesting point about bad ideas being much more prevalent than good ideas. Here at Thayer, of course, we have no bad ideas. Our faculty have good ideas, brilliant ideas, in fact. And to develop those ideas, they, of course, need money. They need funding. Once they have secured that funding, they work with students to undertake fundamental engineering discovery, perhaps develop a computer code that analyzes a system, build gadgets, not gears literally, unless they're at the nanoscale, but certainly mechanical devices. Sometimes we find that those inventions and discoveries have utility. We write a paper in the scientific literature to tell our colleagues what we do. Sometimes we will file for patent protection. And in fact, if you've had a chance to tour Thayer, I hope you have seen the wall of patents that exists upstairs just outside my office, celebrating invention and innovation at Thayer. Sometimes those ideas are in fact commercializable. An inventor, as Eric said this morning, will take a collection of patents, start a company, build from there, build an intellectual property position. Sometimes, much less frequently, an idea that we publish in the open literature will even have some spin-off ideas associated with it that are commercializable. So how do we use the funding that's at the core of all of this? Well, we buy things, right? Laboratory equipment, large and small. Laboratory supplies like chemicals, costs for analysis, tuition support for our graduate students, professor and researcher salaries, stipends for PhD students. One of the wonderful things about the U.S. system of research, higher education in engineering and the sciences is that students pursuing a PhD and sometimes a master's degree are in fact supported through their work to advance scientific discovery and technology development in this country. Without dollars, much of this becomes impossible. So the funding ecosystem is hugely important. To give you a sense of scale, Dartmouth in FY 2016 was just shy of $200 million in sponsored research funding, and Thayer is a little more than 10% of that, right? 1/9, 11% of the total. $22.6 million. May not sound like much, but if you divide that by 40 tenure-track faculty members on a per capita basis, that makes us one of the top 20 or 25 funding institutions, research institutions in this country. My point here is that this is an incredibly vibrant and successful faculty community. This is out of a staggeringly large global research investment of about $1.7 trillion, the lion's share of which, about a third of it, $500 billion, still done in the United States. Jeff Immelt this morning spoke about, I think he said, a $67 billion internal spend at GE on R&D. That's about the size of the entire National Science Foundation. Not quite, but pretty close. So a large corporation spending an incredible amount on R&D. And in fact, if you look at the picture in the U.S. over the past 50 years, the red part is industrial spending, GE being an important and significant part of that. The blue part at the bottom is federal spending. And so in the U.S., the research picture is actually pretty bright. Even in challenging economic times, there's been about 3.5% annual growth. Not bad. Federal picture is a little bit different. 40 years of 1.5% growth. Not quite as good. About 1/3 of the federal R&D is spent at universities. That's about $40 billion, and about 20% to engineering and computer science. And so I put this up here just to give you a sense of the scale. 20% of 40, you all know this, you've done the arithmetic in your head, that's $8 billion. That's about the size across the entire country of what GE spends on an annual basis for its own R&D. And so the point that Jeff made this morning about the importance of federal funding, yet not being entirely dependent on federal funding, I think the scale argument here makes it abundantly clear. In terms of where we are compared to other institutions, the U.S. is the red curve in the middle, and this gives you a sense that we have gone from being one of the world's leading supporters of R&D as a fraction of GDP to somewhere in the middle of the pack of industrialized nations. And if you look at the federal component alone, it's actually been decreasing. And so I tell you that just to present an overall picture and emphasize the point that Jeff made this morning, that R&D investment by corporations is incredibly important to moving technology forward. R&D investment by the federal government is incredibly important to universities. Let's talk about what specifically it does here at Thayer. Well, there was one great story from this morning of what the federal R&D investment enables. You heard the story of Eric Fossum, who back in the day worked at NASA, was challenged to develop imaging technology that was lighter and perhaps, well actually, did cheaper matter? Lighter and better. Okay, cheaper mattered. That's good to know, actually, even to the federal government, cheaper mattered, right? He developed CMOS imaging technology, started a company, reduced the size of image sensors to something that could fit easily on the tip of a finger, commercialized that technology that we all carry around in our pockets today and is now working on next generation imaging technology, all made possible with federal R&D investment and, of course, with corporate R&D investment. Eric is a great example of a successful faculty entrepreneur who's taken fundamental science, developed useful technology, and then commercialized it to benefit the world. He is, however, not the only entrepreneurial faculty member here at the Thayer School of Engineering. Some of you who were students in the 60s may remember Bob Dean. Bob Dean helped develop the early version of Engines 21 as we know it today. Bob Dean started many companies here in the Upper Valley, including Hypertherm with Thayer overseer Dick Couch, who is here in the room somewhere right in front of me. Dick Couch here this morning, and several other companies in the Upper Valley. Faculty member, serial entrepreneur. Tilman Gerngross spoke on a panel discussion yesterday afternoon, serial biotechnology entrepreneur. Eric, of course. Lee Lin, cellulosic biomass pioneer, helping develop a renewable fuels future. Serial entrepreneur here at the Thayer School of Engineering. Stu Tremblay, biomedical treatment, using electromagnetic radiation, treatment of the cornea in particular, several companies that he's started. Laura Ray, serial entrepreneur. Brian Pogue, fundamental engineering scientist within the past 2 years, technology entrepreneur. Carl Griswold, young faculty member we've hired recently, whom you will hear from this afternoon in a panel discussion. Jason Stouth, another member of our young faculty, started a company before we hired him at Thayer and is now working on the next venture. In total, this is a recent list of faculty who have started companies here at the Thayer School of Engineering. It is a list that is, since 2000, including 38 unique companies, 24 unique faculty members, 1 in 3 of our tenure track faculty, most of those located right here in the Upper Valley. My point in telling that part of the story is that this is a culture from the beginning here at the Thayer School of Engineering that has recognized invention and innovation, not only supported it, but celebrated it. I mentioned the wall of patents upstairs in Cummings on the second floor just outside my office. That wall of patents grows year after year after year. And you can look at the timeline, which starts in 1970, look at the time across the top, and see the rapid acceleration. When we put this patent wall up about 6 or 7 years ago, one of the things I said, somewhat tongue-in-cheek, to the Thayer community was it was my sincere goal that we would run out of space, or I should say my sincere hope, that we would run out of space in 2017. Because there's something symbolically and historically important about 2017. Oh, you were supposed to laugh at that. Come on. We will, in fact, go around the corner this year, later this year. When we have our next ceremony this fall, if you look upstairs, you will see that there is now a blank blue wall extending around the corner from the initial patent wall. That is the rate of acceleration of intellectual property development here at the Thayer School. This wall contains every U.S. patent issued for work done not by our community in their careers, but by Thayer faculty, staff, and students while they were here. Those patents are color-coded. Some of them represent student-only invention and innovation, another area for which we are extraordinarily proud. So this level of entrepreneurship, particularly at the faculty side, 1 in 3 of our faculty in the past 15 years, puts us in a position where I can say comfortably and publicly, I'm fairly confident that this is one of, if not the highest levels of engineering faculty entrepreneurship on a per capita basis in this country. We think of Thayer as an incredible undergraduate institution, and it is. You should also think of Thayer as an incredible home of innovation and entrepreneurship and technology creation and development. And our goal as we grow the faculty, which I'll speak to in a few minutes, is to reach a level of 1 in 2, where half of our faculty members are entrepreneurs. And so if you are an aspiring 16-year-old anywhere in the world who wants to use technology, harness the power of technology to make the world a better place, to improve the human condition, to change lives, there is no better place to come and study than right here with this highly entrepreneurial faculty. Now, to do this, of course, requires more than just faculty who are entrepreneurs working in the classroom. It requires educational programs that support this entrepreneurial emphasis. Liz mentioned in the introduction that 4 of us here on the faculty were fortunate to be recognized 3 years ago by the National Academy of Engineering for a community-wide effort here at Thayer, started in 2008, to create the first innovation PhD program in engineering in this country. Several of those students have been with us during this weekend. We bring in a very small number of students under the tutelage and guidance of Eric Fossum and Brian Pogue, 2 of our faculty entrepreneurs, every year, working with faculty on developing ideas into technologies in their lives, learning what it takes to be a technology entrepreneur. They're not required to start a business while they're here. They're not required to start a business ever. But the idea is to help them understand that engineers, in our view, have an obligation to society to do more than just study a problem. Our obligation is to figure out how to put that technology to use. And this program was recognized for helping them do that. It's not all at the graduate level. In fact, many of you here in this room know this is something that this school has done extraordinarily well from the 1960s at the undergraduate level, through a wide range of courses, including a long-standing course that to alums and to students across this campus alike is known simply by its number, which we fortunately have not changed in 50 years. I think we should trademark the course number and never change it. But ES21, or Engines 21. Does anyone know, just show of hands, what the title of the course is? Like 3 people, thank you, right? 2 of them who are on staff. Could anyone? Which is good. I'd like to know why the rest of the staff and faculty hands weren't up. But Boomer, do you know what the title is? Introduction to Engineering, right? That's a pretty prosaic title, but it is entirely accurate, because how do we think of engineering here? It is a class that is about invention and creation. Is it about idea generation? Only good ideas? All right, maybe a few bad ideas that we learn how to evaluate and throw out as we go through the process. It's about encouraging students to take calculated, understandable, and appropriate risk, to recognize that not every idea is a good one, but to learn how to fail and learn from that failure. Those of you who are alums know this course. Let me see a show of hands. How many of you have taken the course? Wow, that is remarkable, right? And I would be willing to bet that every one of you has a story to tell, which I'm not going to ask you to tell right now, but has a story to tell about your experience. One of the great joys for me in my position is I have the great privilege of traveling around the country and even around the world to meet with alumni from all programs and all classes. And I was struck within my first 6 months on the job here of the stories that alumni would tell to one another and to me when they got together about, well, both about building a Stirling engine in thermodynamics, which apparently we've been doing for a good long time, and about their ES21 project, and trading stories, and these are alums from the early and mid-60s, about the devices and the gadgets that they still had in their attic or in their basement, or some cases on a coffee table. Much to the dismay of the rest of the members of their family, I suspect, but they were happy to discuss and proud of. And what's most important and impressive to me is they'd speak about the lessons they learned in the engineering creative process through that course. Right now, today, this year, in data that I just got a week ago, there were over 200 Dartmouth students who took ES21. Imagine that, those of you who are alums from the 60s and 70s, 200 students from across this campus taking this incredibly time-consuming and challenging class in creative innovation. It's this creative culture that I think has led to some of the enormous success we have seen, and Liz mentioned in her introductory remarks, that has led to this wonderfully diverse community here at the Thayer School of Engineering. I will point out here on the right that this N is the national average. Jeff Immelt showed this as well, the fraction of engineering degrees that are granted to women at the bachelor's level in this country. We are approaching 20%. I think last year it was 19.8, plus or minus a tenth of a percent. That's the highest it's been in 2 decades. Not very impressive. This is Thayer through the past decade, and last year we graduated a class that was over 50% women. How do we do this? We don't do this at Dartmouth through the admissions process. We don't do this through deliberately targeted programs. We have done this largely by making engineering an engaging, creative, team-based enterprise focused on the outside world. I'll say again because I can't emphasize this enough. Not technology for the sake of technology, but technology to improve the human condition, to make a difference in people's lives. And that has helped attract an incredible group of talented students from all parts of the campus here to the Thayer School. We have also done some things intentionally and appropriately, and I've had a lot of conversations with other engineering deans over the past 9 months asking about our success. We think carefully and deeply and deliberately about high-quality teaching, particularly in the early classes. We have many women in the classroom to serve as role models, and we think about diverse communities at every step of the process, not just the faculty, but the technical staff, the teaching assistants, review boards that we have asked many of you to participate in at all levels. And it's a remarkable outcome that we aspire to in all of our programs. Here at Thayer, we continue to experiment. I'm going to flip through 3 slides very quickly just to give you a sense of some of the things we continue to try, because there are no bad ideas here at Thayer. Oh, come on. Right. The things we continue to try and experiment to find new ways to engage students from around the campus. And so these are some photographs from what we call our December winter room. We started this experiment 2 years ago. December no longer is part of the academic calendar. Fall term, believe it or not, now concludes before Thanksgiving, including exams. And our faculty asked an important and appropriate question. Why can't we experiment with December? Could we create courses where we, the faculty, and then the technical staff, could teach anyone from Dartmouth who was interested in learning something about engineering just for the sake of learning? No tuition, no credit, no transcript notation, just to learn. So we ran a pilot. We didn't know if any students would show up. We didn't know whether they would remain engaged. Turned out they did. So we've taught courses on basic biotechnology, electron microscopy, how to do an effective search in the library, musical instrument making. Those of you who were here Thursday afternoon got to hear an original composition, a partnership that Thayer had with the Hopkins Center, funded by the Mellon Foundation and a generous grant from Dick and Barbara Couch to develop an original composition that married engineering and the performing arts. It was a wonderful piece of music using instruments that students developed, original instruments, in this December 4.5-day winter class. And twice we've taught classes on interim of things. We have a new course that we put together. Vicki May, a member of our faculty, along with David McCauley, and a MacArthur Foundation Genius Grant recipient and local artist and author. Some of you may know, in fact, some of his books. Many engineers know them well, pictured up there on the screen. He and Vicki developed a course this year on visualizing and sketching information to engage freshmen, first-year students who were not planning to be engineering majors, in some of the wonderfully creative things that engineering can do. We have a new program, a pilot program, in fact, that we're attempting with Tuck and computer science this next summer to develop a 2-week integrated program that we're calling a Tech Accelerator program. Builds off of the Tuck Bridge program that some of you may know well, where we're going to bring together students who are college freshmen and sophomores who are not engineering and computer science majors, and giving them a 2-week integrated intensive experience to SolidWorks-based design, to basic foundational coding, and basic elements of business. We're hoping that will inspire some of them to take classes in computer science and engineering as juniors and seniors. We're hoping it will inspire all of them to consider careers in technology because of its importance to all aspects of life and commerce going forward, as Jeff said earlier this morning. That's a little bit about what we've done and where we're heading academically. I wanted to take a few minutes now to step back and look at the history before I talk about where we're going with regard to our new physical plant. Education and research needs space. And the Thayer School of Engineering is no different than any other engineering school. We need space. And our space, from the beginning, has been scattered in different places on campus until it was assimilated down here on the West End in the 1930s. And in fact, in the very early years, from 1874 to 1892, we were housed in Thornton and Reed Halls, over on the other side of the green. It was wonderful space, so wonderful that, in fact, we were given one basement laboratory in Reed to go along with the small amount of space in Thornton. And a comment from one of the Rauner Special Collections librarians who found these sketches for us is something I put up here. I'd just like you to take a minute to read that to get a sense of how appealing the space was. Right? Cold, dark, and dirty. I hope those words leap out at you in the middle. Some students even preferred to lodge with townspeople rather than stay here. In 1871, the college decided that could become Thayer School space. Enough said. Things have gotten a little bit better since then. In 1892, the Thayer School of Engineering moved completely into the Thayer Lodge, which is over on Park Street today. The building still exists, 6,000 square feet of space. That must have seemed like a staggering amount in comparison to the inauspicious beginnings. 1912, Bissell Hall, which is on the site of the current Hopkins Center. Then in 1939, yes, we've been here that long, we moved to the current location. Cummings Hall was built, giving us the staggering sum of 20,000 gross square feet of space. 1947, Cummings had already become too small and was expanded with wings added, bringing us to 40,000 square feet. 1967, how many of you remember the barn? Ah, yes, the barn brought us to 56,000 gross square feet. 1989, the barn went away. In this space, the Cummings additions were developed, bringing us to 112,000 square feet. And then in 2006, the McLean Engineering Sciences Center opened, bringing us to 176,000 square feet. Our goal and our vision for the future, here in the architectural model next to me, I had another bullet there and I forgot, will make us even bigger than that. Williamson at the medical campus was added in 2015, brings us to 184,000 gross square feet. This addition will double our total footprint and bring us to about 360,000 gross square feet going forward. A remarkable transformation over 150 years. I thought it'd be interesting to take a look at that in relation to the size of the Thayer community. And so what I'm plotting here, you're all engineers or live with or family members of individuals who are engineers, so you see plots like this all the time. So we're looking at, or doesn't everyone have these on their refrigerator? So we're looking at the relationship of time versus total square footage and total number of faculty of the Thayer School. And it's actually remarkable how these have scaled. 1939, the development of Cummings brought us up to 20,000 gross square feet. Through the expansion, brought us up to about 60,000 gross square feet, and you can see our faculty grew from 1, the red dot in 1871, Bobby Fletcher, who, if you've seen the timeline outside, taught something like 36 classes in the second year of existence of the Thayer School of Engineering. We are much kinder to our faculty today, right? To a faculty in the low 20s in the 1960s and 1970s. With the development of the McLean Engineering Sciences Center, growth to 160,000 gross or 180,000 gross square feet, as I said, our faculty had grown into the low 40s. And if you look at the addition of the Williamson Translational Building, see where that brought us. And our goal, in combination with computer science, is to build a total faculty of 100 plus 30 computer scientists, total faculty of 130 within a decade. And that will move our facilities to just about 360,000 gross square feet. Let's take a look at growth in student numbers over this same period of time. You can see here, this is over the past 50 years. These are the number of Bachelor of Arts degrees, so undergraduate degrees in engineering. Those of you who were here in the 70s may have felt as if the classes were about the size of a single classroom, and you are in fact right. Low to mid 30s in that era. Substantial jump along with the growth in engineering enrollments across the country in the late 70s and early 80s brought us to the mid 60s, where with some peaks and valleys, we actually remained for 30 years. Look at what's happened here over the past 10 years. Substantial growth to the point where last year's graduating class was 117, more than 10% of the Dartmouth undergraduate student body. If you look at total Dartmouth degrees, so this includes bachelors of civil engineering and mechanical engineering degrees, which we offered in the 40s and 50s, Bachelor of Engineering degrees, Master of Engineering Management degrees, MS and PhD. You can see where the Thayer School was in the tens from its founding in 1870 until the World War II era. Growth here into the mid-20s, and then look at what's happened since then. Remarkable transformation of an incredible institution. If you look at some of our record-level graduating classes, you'll see, interestingly, that almost all of these have happened within the past 3 years. I've had the pleasure of standing on the stage at Investiture, Thayer School's commencement ceremony, many times and announcing to the graduates and their families that it looks as if we are graduating a record number in a particular program this year. And in fact, I expect that I will be able to do so again this year, 2017, when we are anticipating graduating our largest ever Bachelor of Engineering BE class. The faces of engineering have changed throughout history as well. So has the mode of dress, I will point out. This is our graduating class in 1917. This is our graduating class with members of our faculty in 2016. A wonderfully diverse group on all measures, including intellectually, from a small group of undergraduate students to a strong mix of undergraduates, masters, and PhD students. So let me pause here for a moment and say, through all of this, there have been features that I think have been and are distinguishing characteristics of a Dartmouth and Thayer engineering education. These are things that I emphasize when I speak with prospective students and their families. This slide, in fact, is one that I showed to the Dimensions admitted student group twice in the past couple of weeks, making the point that if you come here for an engineering education, it is a different kind of engineering education. It is the kind of engineering education that we think is fundamentally right for the 21st century. First, the integration of engineering and the liberal arts here is unlike anywhere else in the country, and I truly mean unlike anywhere else. The integration between engineering and the liberal arts is real and profound. It is so deep that I sometimes refer to it as liberal engineering, the notion that it is not one or the other, that is a false choice, a false dichotomy. To truly be educated for the 21st century, one needs to understand technology at a fundamental level and understand liberal arts. One teaches us context and history for understanding the world. Engineering combined with that gives us the tools to go out and change it. Either without the other is incomplete. As I say often to our students and their families, how can you harness technology to improve the human condition, to address the world's problems, if you don't first fundamentally understand the world? We have become one of the largest majors on campus. And in fact, this past year, engineering and computer science combined, if you will allow me to combine those, graduated more students than even economics. Only by one, but more students even than economics. So engineering and computer science combined, which would be part of the same school in many institutions, were in fact the largest undergraduate major at Dartmouth last year. A remarkable change from the 40s and 50s and 60s and 70s and 80s and 90s and even the early 2000s. You all know that experiential learning, a model of interdisciplinary project-based design, here at Dartmouth is fundamentally how we teach engineering education, and it is open to all, not just engineers, particularly through our signature course, ES21 Engines 21. What's the title of that course? Introduction to Engineering. Yeah, right. You really had to work to remember that, didn't you? Right. We are a national leader in reaching gender parity and a national leader in faculty entrepreneurship. So let me close with just a few minutes speaking of the future, and then I'd be happy to take your questions and have a discussion. There is, as you all know, an ambitious 10-year plan here at Dartmouth to grow the faculty in our program. It is first and foremost to accommodate this incredible demand for engineering embedded within the liberal arts, to be able to educate more majors and also make engineering education and computer science education at Dartmouth a fundamental element of a 21st century liberally educated individual's education, to make Dartmouth a leader in defining what the liberal arts of today and of the future needs to be, to expand experiential learning opportunities and touch every Dartmouth student's lives on this campus, as I said, to make Dartmouth a leader. Our plans are to partner with computer science, in fact, to have computer science move in with us in this new facility, and not in a siloed or separated fashion, but completely integrated. I speak of this moment, the moment that Jeff Immelt spoke of this morning, this convergence of the digital and the physical, as a moment of digital integration, a moment where every physical device that's developed and designed is going to have firmware embedded within it to operate it, or analytics that it's generating to optimize operation, or be connected to other devices through an Internet of Things. How can someone be deeply educated in developing physical devices without understanding the importance of the underlying code and analytics? How can someone be deeply educated in developing code without understanding the physical universe that it's connected to? Our vision is to build a facility that brings these faculties together, not just in one building, but in the classroom, in shared projects, co-taught in shared project labs, having laboratories side by side where our computational biologist friends in computer science are next to the faculty doing protein engineering on the benchtop in engineering. That's our vision for the future. To build our research areas that Liz mentioned at the outset and to become clearly the national leader in both sustainable gender parity in engineering education and in faculty entrepreneurship. I've got the numbers here on the slide to give you a sense of the goals for growth, but we anticipate building the capacity to reach every Dartmouth undergraduate student and sustainably support 120 to 150 AB majors a year and up to 200 BE majors, and to do it without losing the core sense of community that makes this such an incredible opportunity and experience for our students. The building, as we envision it, will be on the space of the parking lot right behind me. Please, please don't anyone ask me about parking when I open this for questions. It's a problem I assure you that we are wrestling with. But the idea of building there is because of the importance of community here. We know that to maintain and preserve that which has been so great about this institution through its history, we need to have that deep physical connection to Cummings and to McLean. And so the idea is that the building will be connected by bridges and tunnels, and it will not be, other than housing computer science, will not be disciplinarily segregated. The idea is that, as it is currently, we don't put our computational faculty in one corner of the building and our material scientists in another corner of the building. Faculty are deliberately mixed up. Their offices are not adjacent to their laboratories, to promote random interactions, what I like to call Brownian collisions in the hallways with, that was not supposed to be funny, with one of, I'm a particle scientist, that means something to me. To run into one another, but also to run into students, crossing through the Great Hall, crossing through the McLean Glycophi atrium. This is where these interactions that make this feel such a tight-knit and closely connected community happen. We insist on, we intend to preserve that. And going forward in doing this, we will never forget what it is that has made us engineers from the beginning. One of our distinguished alums and graduates, Sam Foreman, class of 1946, who's here with us this morning, has written many books, including one that spoke eloquently about the existential pleasures of engineering, and also passionately about the importance of engineers understanding society and the intersection between engineering and the liberal arts. That is who we have been from the beginning. This is who we will remain as we go forward. We will never forget that from its founding, this institution has been about preparing leaders to tackle the world's most challenging problems. So let me stop there. I'd be happy to talk about the model, discuss anything we discussed today, or take any questions at all you may have about the past, present, or what we think is a very exciting future of this school. Thanks, everyone, for coming back. Yes? What happened? Do you mean culturally, or what? What specifically are you referring to? The dip in enrollments? So I don't know. I mean, a lot of that is what I will call statistically just noise, year-to-year variation. There was not a fundamental shift in our approach to engineering education. I think nationally there were some trends on the job market. That was certainly the case in the mid-'80s that affected engineering enrollments nationally. We grew after that when it wasn't happening nationally, and I think we just dropped back to national mean. So, I mean, I'm speculating. I truly don't know. Because it wasn't repeated, maybe it was just an era where the person teaching capstone design was particularly difficult and students took an extra year to graduate. I mean, I honestly don't know. I hope I can do a better job answering the next question. Andrew?
Can you talk a bit about the opportunity with the New Energy Institute and how that might help support our goals?
Yes, so as Jeff Immelt mentioned, and as Andrew alluded to in his question, there are plans here at Dartmouth to build the new Erving Institute for Energy and Society. And on this model, actually, the Erving Institute building is planned to sit right here between Murdo, the Tuck School, and Cummings Hall. It, too, will be physically connected to engineering space, both here in Cummings, going past the Cook Auditorium right now, you can enter into the new energy space, and also on upper levels, and it'll be connected to the MEM student space in Murdo. The Energy Institute is intended to be an interdisciplinary place of study and collaboration, looking at all aspects of energy technology development, environmental footprint, renewable fuels, economics, business practices, and societal connection with energy. There will be a strong Thayer presence in the Energy Institute, and in fact, getting to specifics, as we think about our plans for this building, we are planning for up to 4 faculty that Thayer is intending to hire. Remember, we made energy a focus of hiring in this school over a decade ago. 4 individuals we hire will have their labs in the new building. And so we're looking to promote that kind of cross-fertilization and cross-talk between the buildings and between the faculties. So many of our existing faculty will have appointments as Energy Institute faculty as well, and we are hoping to be developing courses and also research opportunities as an important part of that.
Joe, we live in a very globalized economy, and I'm wondering how this new vision is going to play out on a global scale, and where do you see Thayer School kind of embracing this whole global economy that we live in now?
So I guess I'm not. So are you asking about student opportunities to engage globally, or?
Student opportunities, faculty opportunities. Jeff mentioned things that are going on in India that are now calling into this country. So, typically we have this view looking outward.
Right.
Now, what is Thayer School, if anything, going to be doing to bring in some of these global elements as part of this plan?
So I'll answer that in a couple of different ways, and I apologize if none of these get directly to your question. So first, we have an intentionally diverse, globally diverse student body, particularly true at the graduate level, but it's reflected at the undergraduate level as well. 10% of Dartmouth is international. That's true in Thayer at the undergraduate level as well. We give our students opportunities to engage in project work around the world. And so several of our capstone design projects for BE students the past several years have been opportunities to develop technologies for India, for Haiti, and we're looking at a potential opportunity at a remote, in partnership with the Island School in a remote part of the Bahamas this coming year. And so these are sustainable, off-the-grid kind of opportunities for our students to think carefully about technology development. We've got a Dartmouth Humanitarian Engineering group that has been doing work in the summers, engineering design project work in Rwanda and Tanzania principally for the past decade. We have 3 international exchange programs for undergraduate students in Denmark, Thailand, and Hong Kong, where they study engineering in those contexts. Professor Kofi Odami, one of our faculty members who's a native of Ghana, this year is starting another pilot that I didn't mention. It is called ADEPT, the Asheshi Dartmouth Engineering Project Team or something like that. And the idea is that there'll be teams of students in Ghana and Thayer working first electronically, collaboratively, on an integrated design of a technology that's meant to address a medical monitoring condition that's prevalent, or a challenge of detecting pneumonia reliably and accurately in sub-Saharan Africa. So there are things like that that we're trying to do to get our students to engage internationally and to bring some of the international opportunity here to Thayer. Plus, our students study abroad as part of the Dartmouth programs pretty extensively. We also look for opportunities to bring international speakers here to campus to speak about their business development opportunity in the developing world. It's things like that. Yeah. So, how about over here? Yep, you, and then Peter, and then I'll go back up here in the back.
Yeah, I was just wondering, as part of this new addition to the Thayer campus, will there be any renovations done to the Sullivan Library? Would that be part of the larger addition, or is that?
I will put that squarely in the camp of the plans that are developing around the Energy Institute. So I don't know the specifics, but there are going to be renovations done in Murdo, including in the Feldberg space. So yes, Peter?
I have an observation, not a question, and I may be the only person in the room who feels this way, but when you put the first paragraph up there, the Sylvanus Thayer Leonard. I had never realized before that Sylvanus Thayer is a Dartmouth alum. He's always referred to as the father of West Point, but in fact he was the valedictorian of the Dartmouth class of 1807.
That is correct.
And we usually, whenever any alum is referred to, have their class name after them, but I've never seen it listed after to be Sylvanus Thayer, 1807.
I'm trying to, I can't get the slide off the screen. Right? Yes, thank you. Point well taken. I have referred to him as an alumnus, but you are right. In 12 years, I have never put his class year on the slide. All right. I will make that adjustment. Natalie.
I know students are always concerned about project space and how Couch Lab there's always not quite enough space. Is there plans to expand to like an innovation space or just project space work in general?
The entire first floor or first and ground floor of the new building is envisioned to be integrated project space. So the Dolly Lab, if that means something to those of you in this building, will move down and be part of that space. New couch-like expanded space will be available for projects. And we're looking at least one space that will be combined, what I will call digital and physical, where there'll be computer science projects and engineering projects in the same space. Because as students have told me, when I commented one day to a student in my office about how vibrant this place was when I walked through at 10 o'clock at night, she looked at me and said, Dean Helble, 10 p.m.? You should come back at 2 a.m. That's when the magic happens. I politely declined and said I would take her word for it, but the point is to have students from computer science and engineering mixing in these project lab spaces like the Couch Lab or Next Generation Couch Lab in the middle of the night where they're learning from one another, talking about and sharing ideas. That's something we're really excited by. So, yep. Doug?
My question for you, Joe, is maybe not really a question but a thought that I'd like your reaction to. And it came not from anything that's happened here today, but my reading on the Dartmouth Post on the way up here, which involved an issue of the Economist magazine, where the leader and the article internally was on cybersecurity, or what, according to the article, may be better termed minimizing cyber insecurity, because there is no such thing as cybersecurity. And the other 2 points that the article made that were fundamental was one, to get the best possible grip on cybersecurity requires lots of disciplines and lots of approaches.
Yep, including the social sciences and the arts and humanities.
Secondly, that the majority of what's being tried so far ranges from not very effective to positively harmful in some cases. It sounds to me, even though the smorgasbord table is already growing with great ideas, that that's a natural for Dartmouth to, with Thayer at the center of it, to stake out as an important area of advance.
Yeah, that's an important point, Doug. Thank you for making that. Some of you may know for 20 years, Dartmouth, although we've been relatively quiet about it, has had ISTS, this Institute for Security and Technology Studies. And so it hasn't been focused explicitly on cybersecurity, but that's been an important element of some of the research they've conducted, and they've really worked at bringing the social sciences into the conversation, so it's not just engineering and CS. We have a few faculty here within Thayer who focus on issues related to security, principally Steve Taylor and George Sabenko, although certainly not exclusively them. There are a few individuals in computer science, Sean Smith and a few others who have similar interests. They are collaborating on ideas that we hope will expand the faculty in that area. Now, will that become a major and broad research emphasis here at Thayer to the scale of our work on engineering and problems of medicine or energy? Probably not, because we have to make choices, and even at twice our size, we're still going to be truly among the smallest schools of engineering in this country. but it is something that builds on, it's strength to strength. It builds on some of the expertise already resident at Dartmouth, and we will see some expansion of effort in that area. And you're right, there can never be perfect security. There will never be perfect security, and there is going to be a need for university researchers to engage actively in this area. I'll take 2 other short questions and then time to break. So, Z, since you're a faculty member, you can ask me anytime, so I'm not going to take your question. Will, and then I will give, okay, I'll take 3. Will, young woman in the back, and Sam, as a distinguished member of the class of 46, I will give you the final question. So Will?
Joe, the intent is to expand Thayer's footprint in the energy area. Going back on Jeff's theme on strength to strength, historically Thayer's strengths were obviously the biomass area, Hansbrett, Glenn Lee's team, and so on. And then Graham and the fluid mechanics folks doing all their work on multi-phase, modeling around nuclear reactors and such. So when you say expand, you're going to build on the existing strengths, you're going to branch out to some new areas, or you're going to wait and see what the new creative faculty decide to focus on?
Oh, how about yes, yes, and yes, Will? I mean, the goal is always to look for complementarity. And so when we look to hire faculty members, we're looking for people who will bring research and teaching strengths that build on what we've got here, right? So that is going to be the primary focus. But we will be open to new ideas that emerge and work that might take us in a completely different direction. We are not, however, going to decide tomorrow, this new field looks hot, we're not doing anything, let's hire 10 faculty members in this area. I think that would be a bad bet for us. I think we need to focus on fundamentals and what we do well and what we do already. So, Michelle, is that you? I have a light.
A young woman. God, made my day.
Apologies for not recognizing you, but statement not withdrawn. So.
The gender parity, congratulations, it's such wonderful news. I remember when it was announced, over 10% of women on the Dartmouth Facebook group liked that news, and it went viral, I think thousands of shares. I also heard this week that Dartmouth's admissions have an over 60% yield for the first time in a long time. What impact do you think that news had on yield?
I hope significant and positive, but at this point in time, that's complete speculation on my part. I did hear from colleagues in admissions, and this is just anecdotal, but they were reading some essays from outstanding students who were applicants to this year's class who had mentioned that specifically in their application. And so the news is getting noticed. And I will also tell you, with apologies for putting my MEM colleagues on the spot, but it looks as if this year's entering MEM class is going to be close to, if not at gender parity. And so we don't know the reasons, but let me simply say, how many qualifying negatives can I put into this statement? But it's hard for me to imagine that news is not making a difference in some applicants' minds. And we are tremendously proud of that. I think it's the direction the world needs to head. Engineering should be open to and embracing every student who's got a passion for using technology to make the world a better place. I would love to see more institutions look exactly as we do. So thanks for your question, Michelle. Mr. Floorman.
When the Navy came to Dartmouth in 1946, and I enlisted in the Thayer School program, I was asking about the Thayer Tuck, Thayer program, which was just being introduced as something very, very useful. I was told by the captain, if you want to end up swabbing the decks, you will go with the joint program.
I called on you because I thought you were going to toss me a softball at the end. Go ahead, Sam. Finish your question.
If you want to be a useful officer for the United States Navy, you will stay with Thayer and forget that crazy idea of a business joint degree.
Right.
To Tuck School and Thayer and the relationship. I could have looked it up.
Yeah. There are many individuals here, including many members of our Board of Overseers, who were graduates of the Tuck Thayer program, and I think they might have a slightly different view of the value of the program than that Navy captain did when you were here as a student. That program came to a close officially in the 70s, but really by the late 60s. It happened in part because Tuck changed their view of business education to one that is now the model for all of the leading business schools, and that is to really emphasize admission of students who have 3 or 4 years, 2 or 3 years of outside business experience, to not take students directly from their undergraduate program. But in the 1980s, and in fact 1988, 1989, Charles Hutchinson, Hutch, who was the dean here at the time, along with the Thayer board and members of the faculty, created the Engineering Management Master's program that Jeff Parker, sitting here at the end of your row, now oversees. And that MEM program brings in about 50 students a year who are interested in this intersection between engineering and business. These are engineers who want to learn business fundamentals so that they can move their careers in a direction, let me be bold and say not dissimilar from the direction that Jeff Immelt's career, a mathematician, took him, where you're in a position to be making investment and management decisions, but that are firmly grounded in an understanding of technology. So I have a more positive view of the relationship with Tuck, right? And it is something we're proud of. So thank you all. Lunch is in the tent outside. Thanks for coming back.